we know that AV is equal to lambda V, where this is the eigenvalue and this is the eigenvector. So if A is a D by D matrix, we may have D eigenvalues lambda 1 to lambda D and D eigenvectors V1 to Vd. Most of the numerical packages that you use for computing gives eigenvalues in the decreasing order. So they need not be equal, and very often when the A matrix has certain structure, you start to see the eigenvalues decreasing very steeply. Now this can be compactly now written as A into V1, V2, Vd, the capital V matrix with eigenvectors as columns, lambda 1 V1, lambda 2 V2, lambda d Vd. Or more compactly, this is AV is equal to V capital lambda. This is a diagonal matrix with all the elements as eigenvalues. Or you can write this also as A is equal to V lambda and V inverse. Where V is the vector of V is a matrix with columns as eigenvectors, lambda is a diagonal matrix with eigenvalues, and V inverse is the inverse of this matrix. In the case when A is real and symmetric, we know that eigenvectors are orthogonal and your V inverse becomes V transpose, or A becomes V lambda V transpose. Now what does it mean to us, or what can we do with this? Let us look at two quick applications of this. The first one, when A is equal to V lambda V transpose, if you want to find A inverse, what should we do? This is nothing but V lambda V transpose whole inverse. A, B, C whole inverse is C inverse, B inverse, A inverse. This is nothing but V sigma inverse V transpose, because the V inverse will be V transpose. So this is, and what is sigma, the lambda inverse? This is the diagonal matrix with elements as 1 by lambda 1, 1 by lambda 2, 1 by lambda d. Let us go back and see this matrix again. Another way of writing this is A is equal to sum over I is equal to 1 to d lambda I vi vi transpose. Now, if lambdas are in decreasing order, remember VI transpose is a D by D matrix. This can be written as lambda 1 into a D by D matrix plus lambda 2 into a D by D matrix plus lambda D into a D by D matrix. So if you truncate this summation at somewhere here, we take only say D prime terms, then what we are going to get is a new A matrix. If you compute sum and get a new A prime, this A prime is a D prime dimensional, say rank matrix. So this is a D by D matrix of size D, of rank D prime. And this quantity, which is a very small quantity if the eigenvalues were very, very small. So for the type of matrices that we are generally interested in with hugely different eigenvalues, so this sort of trick will become very important for creating a lower rank approximation of a given matrix.